All right, going to open up your textbooks to page 158, and I want to do just a couple problems with you very quickly. Number 12 on page 158 says that y is equal to the arctangent of 1. And yesterday, as we looked at these inverse trig functions, we said that the question to ask for an inverse trig function is always the question, when? For an inverse function, the question is when. When is tangent 1? Well, a couple quick recommendations I'd make here about this 1. Put it over 1. You might even want to write in the understood positive. So when is tangent 1 over 1?
45.
At 45 degrees. But you might also ask the question, when is tangent positive? When is tangent positive, class? In quadrants 1 and 3. However, if this had said the tangent of theta equals 1, then I would say 45 and 225 to get all my answers from 0 to 360. In fact, I could just keep going around and around. Infinite number of answers, right? But it wouldn't be a function with infinite answers, would it? To be a function, you're only allowed 1. So for all of our trig functions, not just tangent, we've limited the range. What is arctangent's limited range, class? Negative 90 to 90, or pi over 2, negative pi over 2 to pi over 2, in brackets or parentheses? In parentheses, because remember there's going to be asymptotes at the ends of the range. So which quadrant just got ruled out like that?
3.
Quadrant 3. So I'm only allowed to use the quadrant 1 form of 45, so our only answer will be 45 degrees. By the way, what is arc sine's limited range?
0, 90. Negative 90, 90.
But in brackets. Negative 90 to 90, but in brackets, remember. What about arc cosine?
0 to 180.
0 to 180 in brackets. What about arc cotangent?
0 to 180 in parentheses.
0 to 180 in parentheses. So the sine and cosine, let's recap it real quick. I was trying to do it orally. I think maybe it'll be best if we go ahead and write these out. So arc sine's limited range, we said, is
Negative 90.
and again, if you think about it, good, in brackets, I just said that. If you think about it, it can't be 0 to 180 because it's positive, right? We've got to have the negative positive. But arc cosine,
0 to 180.
because remember, there we go in the brackets, thank you. Remember, arc cosine positive in quadrant 1, negative in quadrant 2. So we're fine to do 0 to 180. Remember that these two are going to closely match the first two, but in parentheses. So arctangent,
Negative 90, 90.
negative 90 to 90 in parentheses. Arc cotangent,
0 to 180.
0 to 180 in parentheses. And then remember, these last two are going to mirror their reciprocals. So arc secant, class.
Negative 90.
No, 0.
Remember, arc secant matches up with cosine.
0 to
So
180 except at 90.
0 to 180 except at 90 degrees. There's an asymptote in the middle of the arc secant, but also brackets. So it really is a dead match for cosine with an exception in the middle. So arc cosecant, class.
Negative 90 to 90 except for 0 in brackets.
There we go, in brackets, and then we'll say except at 0 degrees. All right, again, we could use 0 pi and pi over 2 for your radians there. Let's take a look at number 14. It says that y is equal to the arc secant of 2. Well, again, probably want to put that 2 over 1. Wouldn't be a bad idea to also put understood positive. And then we ask what question? When. When is secant 2 over 1?
30. No, 60.
At 60. The adjacent would be 1. Remember, hypotenuse over adjacent at 60. When is secant positive? All right, but what is my limited range for arc secant? 0 to 180 except at
90.
So that rules out quadrant
4.
and I'm stuck once again in quadrant 1. My answer for y, 60 degrees. Questions on this? At your seats, do 11 and 15. They're on page 158. Numbers 11 and 15, they're on page 158. number 11. The question to ask, class, is when. Specifically, what might we ask first, Quentin? When
is sine square root 3 over 2?
Great question. When is sine square root 3 over 2?
60.
At 60 degrees. All right, another when question we should ask, Jamie, would be when is...
Sine positive.
And when is sine positive?
Quadrant 1 and 2.
All right, but when we think of arc sine's limited range, we can only use quadrant 1. So we end up with y equals 60 degrees. How many have that for number 11? All right, question?
No, I just forgot to do the other stuff.
Okay. Number 15, excuse me then, Chris. Here, it just looks weird, right? Like, y is equal to the arc cosecant of 2 squared of 3 over 3. What's going on there?
I didn't realize till after I did it, but you can't use a calculator, so I used a calculator and I found out it was 60 degrees.
All right, but that's not what we want to do. What should we do?
Take the reciprocal.
I suppose we could. It just looks weird, right? 'Cause, like, for instance, we know cosecant's 1 over what?
Hypotenuse over opposite.
Right, and we're going to start with what question?
When is cosecant 2 times square root 3 over 3?
Right, but we don't have any triangle where 2 squared of 3 is the hypotenuse and 3 is an opposite, right? So because it looks weird, we need to fix it. We need to make it look like something we would recognize. Ethan, help?
It's 2 over square root 3.
Yeah, this was originally a 2 over square root of 3 that they rationalized, and that's where the square root of 3 over 3 came from, right? They just rationalized, but it's really 2 over square root of 3. So if you'll think that through, it'll help you because we do have a triangle with hypotenuse 2 and opposite 3, or square root of 3 rather. And of course that angle would be 60 degrees. But Chris, we also have to ask the question, when is
Cosecant positive.
and when is cosecant positive?
1 and 2.
1 and 2. But arc cosecant is limited to what? Gotta have that memorized, class.
Negative 90 except at 0.
Negative 90 to 90 in brackets, except at 0. So we gotta make sure we've memorized those limited ranges we've been practicing. So if negative 90 to 90, that doesn't jive with both of these quadrants. It'll only ever jive with one. Which quadrant falls into this range?
1.
Quadrant 1. Quadrant 2 would be past 90, right? So quadrant 2 doesn't fit. So we're going to go with the quadrant 1 form of 60, which is 60 degrees. But this is the reason why we would do it. And we're doing it without the calculator for the mental practice. So we will get to the calculator a little bit later on. Now for your homework, you did ones that were a little more involved. You did numbers 19, 23, and 27. So if you would go and have those out. Number 19 gives y is equal to the cosine of the arc cotangent of the square root of 3. So I have two different trig functions here. I've got a cosine, I've got an arc cotangent. Which one do we do first, Ethan?
The arc cotangent.
The arc cotangent, because that's in the parentheses, right? I've got to simplify all of this so I know what to take the cosine of. I'm going to take the cosine of something, but I need to simplify this down. Now, it's important to remember that when you have an inverse function class, the question is when. So I'm going to start with the question of when, and once I've gotten something, I'm going to go to the cosine rather, where the question becomes what? Because it's not an inverse function. Also important to note, an inverse function will always produce what kind of answer? Some sort of degree or an angle, right? It'll always produce some kind of an angle. Where a regular function always produces a ratio, right? Opposite, adjacent, hypotenuse, in some kind of ratio, right? So we're expecting to get an angle, and we're going to use the question when to get it. So on number 19 from the homework, Jamie, you started with asking when is
cotangent square root 3 over 1?
And the answer is at
30 degrees.
30 degrees. But you also had to ask when is
Cotangent positive?
And the answer there
is 1, 3.
But arc cotangent is limited, Jamie.
0 degrees to 180 degrees.
In parentheses, right? Because there's asymptotes on the edges. And so we're going to rule out quadrant
3.
And so the angle that I'm going to get here is going to simply be
30 degrees.
The quadrant 1 form of 30, which is, of course, 30. Now the question, class, as we said, changes to what? What is the cosine of 30? And this is what we've been doing since the beginning of the year. What is the cosine of 30, class? we're done. Super easy. As long as we take care of the first part, then the second part falls into place. Questions?
Where did you get the 0 and 180?
That's the limited range of arc cotangent that we're memorizing. Okay, we're memorizing that. Okay, looking at number 23, we have y is equal to the arctangent of the cotangent of 3 pi over 4. This time, we're going to start with what, Quentin?
The cotangent.
The cotangent. And when we're solving cotangent, my question is going to be what? And I'm going to get a ratio. Then the question in class is going to move here to the arctangent, where the question becomes when, and I'm going to be getting an angle. Okay, but we're starting here with what? And we're expecting a ratio. Well, my first question, because I see radians, would be what
is your reference angle?
And anytime there's denominator 4, I know my reference angle is
45.
45 degrees. Again, this is what we've been doing since the beginning of the year. I would also note that 3 pi over 4, I would ask myself, what quadrant are we in?
Quadrant 2.
And then I would ask myself, okay, now that I know it's reference angle 45, quadrant 2, what is the
ratio?
What's the cotangent of 45, right? What is the cotangent of 45? 1 over 1. And I would also say, what is cotangent in
Quadrant 2.
Quadrant 2, and the answer there is
Negative.
negative. So then with y is equal to the arctangent of negative 1 over 1. I expected a ratio, and I've asked a lot of what questions. What's the reference angle? What's the quadrant? What is the cotangent of 45? What is cotangent of quadrant 2? But now, Chris, the question becomes, when is
tangent negative 1 over 1?
Well, let's just start with the 1 over 1 for now. When is tangent 1 over 1?
45.
45. We might also ask ourselves the question, Chris, when is tangent
Negative.
negative? And that would be in quadrants
2 and 4.
All right, but we also need to consider for arctangent, there's a limitation. I can't use 2 and 4. What's the limitation? You can look if you need to on arctangent.
Negative 90 and 90.
Negative 90 is 90. Well, that's going to rule out which of these two quadrants?
4 and 2.
No, one of these quadrants has to fit within that range. Does quadrant 2 fit in that range, or does quadrant 4 fit in that range?
Quadrant 2.
So from negative 90 to 90, quadrant 2 is in there?
No, 4.
Quadrant 4. But normally for quadrant 4 form of 45 class, we're saying 315 degrees. Well, that doesn't fit in the range necessarily. Quadrant 4 only includes negative angles. So instead of going around 315, let's go backward how far?
45.
45. So we're going to say that our answer, our angle that we're getting from the inverse function is?
Negative 35.
Where'd you get 35 from?
I don't know.
We went down how far to get to the 315?
45.
45. So negative 45 degrees. Does that make sense?
Yeah.
All right. So the 45 in quadrant 4 is down 45 or negative 45. How many had that on number 23? All right, Chris, does it make more sense now?
Yeah.
Jamie, questions?
I didn't do the negative. I was confused on that part.
All right. It makes sense, though?
Mm-hmm.
All right. Let's take a look at number 27. The last one you had for homework was y is equal to the tangent of the arc cosine of, is that a negative half or half? Negative half. All right. I'm going to start with what question, Ethan?
When?
When is,
Cosine half.
all right, answer?
It is 60 degrees.
I should also ask the question, Jamie.
When is it negative?
Okay, answer?
When it's 2 and 3.
But, Quentin, you can't have 2, right? It's an inverse function. We're limiting it to 1. So our cosine
is the range is 0 to 180.
in brackets. So that's going to rule out.
Quadrant 3.
So I'm going to have to go with,
Quadrant 2.
which is
120.
120. So remember, the question is when, and I'm going to get an angle. We got an angle, Quentin. Our angle is 120 degrees. Now, Chris, the question changes and becomes what? For instance, we might first say, well, what? We have a 120 degree angle. What
Reference angle?
reference angle is that? And of course, it's
60.
60 degrees. We just saw this. That's not a hard question to answer. We also would ask what
Quadrant.
quadrant, but again, that's not hard either.
2 and 3. Wait, no.
120 is in quadrant
2.
2. Earlier, quadrant 3 had been an option for this, but we know that where the 120 came from. We said it's a quadrant 260. So we turn right around and say, well, what quadrant are we in? What's the reference angle? We already know it's 60 in quadrant 2 because we just found that. Now the question moves to what is...
Tangent of 60.
Right, and what is the tangent of 60?
Square root of 3 over 1.
Good, or just square root of 3. And we should also ask ourselves, Ethan, what is tangent in...
Quadrant 2.
And the answer is...
Negative.
So we're going to get negative square root of 3 for our answer. Questions on 27. Questions on this?
We do a quiz.
Not yet. Let's take a look at number 29.
It's easy, I know. Right.
Number 29. Ethan wants a quiz. All right.
Make up my grade.
All right, number 29. And this one's a fun one because there's 3 parts to it. We have y equals the secant of the arctangent of the cotangent of 5 pi over 3. What do we start with here, Jamie?
Start by asking, maybe start by asking what?
Okay, because we're starting with what part of this?
Oh, the cotangent.
Right, the innermost thing is the cotangent, right? We've got this is outside parentheses, here's inside parentheses, here's an even insider set of parentheses. So we're going to start here, like we always do, inside out. And we're going to start with the question of what, as she said. For instance, Jamie, we'll start by saying, for instance, what?
Angle, or what quadrant?
Sure.
It would be in quadrant 3, 4.
5/3. This is 3/3. This is 6/3. Or is 5/3 closer to 3/3 or 6/3? So quadrant 4. There we go. Again, that's how to think through it. We should also, while we're on the topic of what, ask Quentin.
What's the reference angle?
What's the reference angle? And anytime it's denominator 3,
60.
always 60 degrees. So then, Chris, we continue with this what, and we say, well, what is?
Cotangent of 60.
And the answer is?
1 over square root of 3.
And I'm not going to rationalize it because I'm going to wait till the very end. So I'm going to leave the 1 over square root of 3. But there's one more what question to ask, Ethan. We said what is the cotangent of 60, and it's 1 over square root of 3. But we should also consider what is...
Cotangent of, what's the, is it positive?
Yeah, what is cotangent in quadrant 4, and it's going to be... Negative. All right, so all of this got us a ratio, right? We asked what, we get a ratio. We asked what, we got a ratio. So now, we're ready to take the next step, Jamie, which is just change the question to...
When?
When is...
Tangent negative 1 over square root of 3.
Well, let's make that into 2 questions. Let's just start with the negative, for instance. When is tangent negative?
In 2 and 4.
And then we would also ask the question, Quentin, when?
When is tangent 1 over 3?
1 over square root of 3, and the answer would be?
30.
30 degrees. But you're not allowed to have 2 of these, right? This is limited, so it only gives you 1 answer. What is arctangent's limited range, Quentin, or Ethan? Chris,
99.
you. You're like a parent at home now. All right.
Negative 99.
Negative 99, right. You!
That
My
one.
mom calls me by like the dog's name so many times trying to call my name.
Does I call you Fido or Rover?
Franklin,
All right,
She calls me Franklin.
Franklin, all right. Well, that's at least a distinguished dog name. You know, it's like Fido. Hey, Fido, come here and make your bed. You know, it's Rover. It's Franklin. You know, it's somewhat distinguished.
Yeah, that's very, very sophisticated.
It very, very much is. What?
Franklin hates me.
Oh, he
His
does.
dog?
Yeah.
If I were a dog, I would. I'm just kidding. All right. So back to Franklin over here. Should have told me that. We're going to narrow this down, right? Instead of quadrant 2 and quadrant 4, I've got to pick one of them, and it's based right here. Which quadrant? Quadrant 4. But normally, reference angle 30 class, we're saying 330, right? I can't do that, Chris. I've got to say
Negative 30.
negative 30. This is supposed to give me an angle if I ask the right when questions. I asked the right when questions. and I got my angle, negative 30 degrees. Now the question, Ethan, becomes,
Oh, what?
what? All right, what do I do when I have a negative angle? Might be a good question to ask.
Secant, it turns into a positive.
Good, with secant it just falls off, so it might as well just be the secant of 30. That makes my next question really easy, Jamie.
When is
Now, not when,
what
is the,
secant of 30 degrees?
yeah, what is the secant of 30 degrees?
Square root of 3 over 2.
Ooh.
No, 2 over square root of 3.
2 over square root of 3, which now that it's a final answer, I do have to rationalize.
It's 2 times the square root of 3 over 3.
And there's my answer. Questions on this? It's just a progression. If it's an inverse function, make sure you ask the right when questions. If it's a regular function, make sure you ask the right what questions. Anytime it's a regular function class, you're going to get a ratio. And anytime it's an inverse function, you're going to get an angle. All right? You're going to practice with that a little bit more in the homework this evening. For now, though, as yesterday we were supposed to get here, we didn't get here, and that is using your calculator to find inverse trig functions. So next thing in your notes, and you've actually done a little of this before, there's just a little something more we need to go over with this. We've already kind of done this. In fact, we used this to check some of our answers. We had to use this to get some answers earlier when the ratios didn't work out as special angles and such. Let's get your calculators out and ready. And just by way of review, if I asked you to find the arc sine of 0.78, put it in degree mode, and what is the arc sine of 0.78?
51.2.
51 point, has 2.6, blah, 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 and generally I like 1 decimal, so let's say 51.3 degrees. But what if I wanted it in radian mode? I could take what's on the calculator times pi over 180, or switch the mode to radians and take the arc sine of 0.78 again.
0.89.
And now it's 0.89. Yeah, let's just say 0.89.
So take the radian, or change it to radians, do what?
Put it in radian mode, and then do what you did a second ago, arc sine of 0.78. But in radian mode, it'll give you a different answer. In degree mode, it's 51.3 degrees. Remember, a whole radian is 57.3. It's just a little smaller, 6 degrees less than a radian. Now, it's just a little smaller than a whole radian. A whole radian would be 1. This is 0.89, or almost 9/10 of a radian. If I wanted you to find the arc cosine of negative 0.45, put it back in, well, let's stay in radian mode, actually. Negative 0.45, and take the arc cosine.
2.0.
Okay, 2.04. We'll go 2 decimal places here. Or put it in degree mode. Remember, you have to tap twice because the first tap puts it in gradient mode. Go back to degree mode, and once again, the arc cosine of negative 0.45.
116.7.
Good, 116.7 degrees. Everyone keeping up? We're good to go with this. Any questions?
Can you let me set it up in the right? How to do it? Right?
Oh, because for you, it's hard to go back and forth.
Yeah, I just do times pi over 180.
Clear.
Here, it's in, that's in there.
Okay. Shift. Okay, so you do
Yeah.
shift setup, and you can tap 4, and now it's in radian mode, or shift setup and tap 3, now it's in degree mode. So what you'll probably want to do as we do exercises is do all of your degrees first, then go through and do all your radians next. Because for you, it's a little bit more involved to go back and forth. For us, it's really easy, but whatever. All right, so let me make sure Ethan's good to go with these values. So go ahead and find them in whatever mode you're in there. You three with the easier calculator. Y'all are good? All right. Let's do the arctangent of 1.7. And in radian mode?
1.04.
So I'll just go through all degrees and then I'll go through all the.
Might be best in your case. Yeah, I'm kind of taking them one at a time here with them right now, but obviously when you do exercises, you'll be able to do them in sets that way. Now, these were easy, right? Because you have a button that the second function is arc sine, arc cosine, or arc tangent. But if I had the arc cotangent of 0.63, I don't have a button for that. So what am I going to have to do? I'm going to have to take the reciprocal function of the reciprocal value. So this is going to change to the reciprocal of arc cotangent of the reciprocal of 0.63. Does that make sense?
4.5.
So, in other words, the arc tangent of 1 over 0.63. Now on your calculator, perhaps the easiest way to do this is to go and type the 0.63, and we go back to degree mode, 0.63, hit the reciprocal button, and then do the arc tangent, which would give you
57.78.
good old round to 57.8 degrees. Let me make sure everyone's able to get 57.8 degrees. Not from Jamie. Quentin gave it to me out loud.
So 0.63.
3. Then hit the reciprocal. Now take the arc tangent. Because you can't actually take the arc cotangent.
Oh, I'm still in radians mode.
So you go like 1 over 0.63 and then you do the arc.
Well, in your case, you do arc tangent first. And then you do 0.63. And then hit that reciprocal x to the negative 1. Don't you have a button for that? Yeah, there it goes. And when you enter, boom, there it is. So reciprocal functions are tangent, then do the reciprocal of the value. All right, now go to radian mode, and let's do it again. 0.63, take reciprocal, arc tangent is how many radians?
1.22.
1.01, barely bigger. Remember, 57.3 degrees is a radian. Tiny bit bigger than a whole radian there. Questions? Chris? Sure, it's radian, not gradient. Those two are right next to each other, so it'll be a challenge. Got it now? Okay. Well, let's do a similar thing with let me erase this. The arc secant. Let's do arc secant now of 2.5.
That's what I got.
Put back in degree mode. And let's do 2.5 reciprocal arc cosine. Yeah, 66.4 degrees or
1.15.
Oh, 1.10. By the way, you could set the calculator to do the rounding for you. Remember, second fix 2 or second fix 1 if you're doing the degrees, right? Questions? Good to go on that one? What if we had the arc cosecant of negative 4.8? Negative 12.0 degrees. Now remember, it's going to give you a negative angle because arc sine is limited between negative 90 and 90, isn't it? Whereas, for instance, when you had the negative on cosine, or arc cosine, it gave you a quadrant 2 angle. Because remember, arc cosine is between 0 and 180. When it's between negative 90 and 90, the angle comes out negative. And of course, we can also put that into the radian mode. Negative 4.8 reciprocal arc sine. And we get?
Negative 0.29.
And there we go. Questions on this? Now, there is one little detail. So this is something we'd actually already done in the class, but there's something we hadn't seen. What if we had the arc cotangent of negative 1.2? Well, again, we take the reciprocal of the, put it in degree mode first. We take the reciprocal of the negative 1.2, and then we take the arc tangent, right? To get? Negative 39.81, blah, blah, blah. Well, it might be 8.1 actually. I've got the fixed on, so 805, blah, blah, blah. I was about to say, I think I might be lying. There we go. But notice arc cotangent shouldn't have a negative angle, should it? Arc cotangent should be between 0 and 180. How do we get a negative angle? Because we didn't use arc cotangent on the calculator, because we don't have it. What did we use? We used arc tangent. Arc tangent's from negative 90 to 90. So the calculator is going to do exactly what you said. You said arc tangent. It gave arc tangent value between negative 90 and 90. But this is not an acceptable value for arc cotangent. It's the only time this is going to matter. Look over there. Sine and its reciprocal cosecant, same range. Cosine and its reciprocal secant, same range. It's just a problem for tangent and cotangent because they're reciprocals, but they don't have the same range, right? So the only time, and arctangent's not an issue because you can do that directly. The only time you have an issue, write this in your notes, is arc cotangent of a negative. If you ever have arc cotangent of a negative, every single time it's going to do this to you because it doesn't know how to do anything else. So anytime you have arc cotangent of a negative, it's going to give you a negative angle because you're actually using the arctangent button. So what you're going to have to do is put this into the 0 to 180 range. Why do I take a negative angle and put it within 0 to 180? Add 180. If I had a 360, it would give me the quadrant 4 angle, but I don't need a full quadrant 4 angle. I'm only allowed quadrant 1 and 2. So the rule of thumb is, make sure this is in your notes, if you have arc cotangent of a negative, add 180. So plus 180. And what's the angle that fits within our cotangent's range?
140.
140.2 degrees. That's the only thing that'll trip you up. You're good on all the reciprocals, and all the reciprocals are fine except this one. Arc cotangent of a negative is going to mess you up because you're going to have to add the 180 because it's going to give you a number that doesn't fit in the range. That's the only thing to watch for that's different from what we've done before. Any questions? All right. It's never been an issue before. Now it's an issue. All right. Any questions on using the calculator? All right. Your homework for this evening is to do page 158. Page 158, numbers 13, 17, 21, and 25. Page 158, numbers 13, 17, 21, and 25. Then on page 159, you're going to practice using your calculator on 31 through 36. Numbers 31 to 36. We're going to have a test coming up in lesson 83. For you guys, that's on Tuesday, but if you're watching on YouTube, lesson 83 will be your test Tuesday. We'll be wrapping up the section tomorrow. We'll be in lesson 81. We'll be reviewing Monday, lesson 82, for the test Tuesday, lesson 83. There is no new material after this test. This is test 5 you're about to take. There's no new material. You're going to have 3 review lessons, and then we're going to take the exam, which will cover everything from the semester. All right? That exam, by the way, if you're watching YouTube, will be lesson 87. For you guys, that'll be a week from Tuesday. All right, so test Tuesday, or excuse me, a week from Friday. A week from Friday. So lesson 87 will be the exam. All right, questions on that? All right, have a wonderful rest of your day.